Welcome to Dr. BT's Chemistry Essentials, A-Level Chemistry Made Easy. In today's lesson, we're going to be looking at Year 1 rates of reaction and focusing on these two specification points. So if we focus in on a typical reaction, where the reactants A and B turn into the products C and D, then the rate of reaction is how fast, so over time, the A and B reactants collide to form C and D as the products. So in order to measure this as chemists in the laboratory, we need to track some sort of physical property of either the reactants or the products. And so how fast the rate of reaction is how this change in property occurs over time, shown like so. And so this equates to the amount of reactant used or the product formed over time. The units of rate of reaction depend on the change in property that you have basically been monitoring. So if, for example, C is a gas as a product, then one thing that we could be monitoring is the volume of gas produced. And so the units would be typically in centimetres cubed for the change in property, and then imagine we are looking at this over time in seconds, so it'll be S minus 1. Another thing we could be monitoring is the mass of the whole system, the system being all the reactants and products in one piece of equipment, say a beaker, and so our units would be grams per whatever time it is. So if it was minutes, it'd be grams per minutes minus 1. Finally, if you could monitor and calculate the moles of something, then it would be mole per time unit that you're looking at. So next we have to start thinking about how we monitor the rate of reaction of, say, a typical one such as AB going to CD, and this all depends on what situation we're looking at. For example, if A, B, C or D are a gas, we can track how the volume changes or how the mass changes of the whole system. So for example, with change in mass, if we added the reactants A and B together, and for example C or D was a gas, so one of the products was a gas, we could imagine that over time that the mass of the whole system of the reactants and products will decrease as C and D diffuses away. The experimental method involves using a balance in order to track the change in mass, a conical flask that also has a piece of cotton wool in the neck in order to prevent any loss of liquid. So when the reaction starts, you start a stop clock, you take mass measurements at regular time intervals, and then you can equate that with the rate of reaction. So really, you're going to end up with a table that has time down one side and mass on the other side. Another approach that you can use is change in the gas volume, because if a gas is given off, you can measure and collect the amount of gas given off using two different types of setup. You can use an inverted measuring cylinder where you displace the water, or a gas syringe. The gas syringe method basically uses a gas syringe that's connected to a conical flask with an airtight seal, and so as the gas is given off, it goes through the bung and basically displaces the syringe, and so you can make a measurement. And so over regular intervals, you take a reading of the volume that is given on the graduated syringe, because there will be some sort of units on there, and then you track that. The inverted measuring cylinder actually at A level uses a burette because you get more accurate readings. So we have our conical flask and a trough with a delivery tube connecting the two. And then we have our burette that is filled with water. Now, as the gas escapes from the conical flask, it comes through here, displacing the water, and then we can take a reading from the graduated burette and that gives us our volume of gas produced. And so with all these techniques, you end up generating a data table with time on the left-hand side or on the x-axis, and then the property that you're measuring on the y-axis. And you're tracking that over regular intervals and just recording basically a volume that is produced. So it could be obviously at 0, 0, then 2, then 4, etc. And this is called continuous monitoring. Other techniques you can use involve looking at other properties. An example of these properties could be colour, and you could use a colorimeter to see absorbance over time, or you could use how long it takes for a cross to disappear. Colorimetry works for any of these methods as long as A, B, C or D are coloured, and obviously if the reactants are a coloured solution and they decrease over time as they get used up, then we see our absorbance decrease. But vice versa, if the products are coloured, then we'd see their absorbance increase. The disappearing cross method is particularly useful if you've got a clear solution to begin with, but then over time it becomes opaque, whether that be because a precipitate is produced. Common examples of the iodine clock reaction. Finally, if there are ions either produced or used up, we can use either conductivity measurements using a pH probe, more about this in year 2, or if it's the ion H+ that's responsible for acidic solutions, then we can use acid-base titration. And so this concludes all the different types of methods that you could use depending on the situation you're given to enable you to do continuous monitoring. So it's your job in a question to look at the reactants and the products and think, do they fit any of these categories of physical properties, and then select the most appropriate method for monitoring its rate of reaction. So next we're just going to finish up by looking at how, once we've then recorded this, we calculate the reaction rate from gradients of the graphs produced. So imagine we are looking at the reaction between magnesium and hydrochloric acid, and this is producing magnesium chloride plus hydrogen. And so when we have tracked this reaction, we have been focusing in on the production of hydrogen gas, and we've been monitoring that by one of our gas collection methods, so gas syringe. And what we saw is at the very beginning of the reaction, no hydrogen is produced, but because there's lots of magnesium and hydrochloric acid particles, there's lots of collisions, so we have a fast rate of reaction. This then starts to slow down as the magnesium and the hydrochloric acid is used up, and then it plateaus off until the end of the reaction here. And so we've got all of our hydrogen produced that we would. So the rate of reaction changes as we continuously monitor the reaction throughout the whole reaction until it becomes 0, and it's 0 where here it lays parallel to the x-axis. Notice that the y-axis is given volume of gas made in centimetre cubes, so we can be sure that we have been measuring hydrogen gas being produced, because that's the only gaseous species on here. And also it's a product that we're looking at because it has increased over time. Obviously, if we were looking at reactant, it would follow a different curve as it decreases over time. So the data this would have come from is 2 columns, time minutes, which equates to the x-axis, and volume of gas produced in centimetre cubes, which equates to the y-axis. If you were asked to work out the rate of reaction at a certain time, so for example 2 minutes, the job that you need to do is to work out the gradient at this point. So here I'm basically going to place a straight ruler against it, and then I'm going to draw a gradient along the tangent of that curve. Now, the reason why I know that this is a good tangent is because you should have about an even area for this side and this side of your tangent line. And to work out the gradient, It is change in y over change in x. If you're ever given an exam question, ensure that your tangent line definitely bisects one of the axes. Here I've made sure I've extended my line to bisect the y-axis at this point here. It will just make any calculations of this equation so much easier. Working out a gradient is looking at the change in y over the change in x. The first two lines you should draw to help you come up with this are made easy if you have extended this tangent line into the y-axis. So the first one I'm going to draw is here, and that's because of the fact that we have the tangent line bisecting the y-axis. And then I'm going to just choose anywhere else that has a solid line on the x-axis. So 3 minutes is really good here because it'd be really easy to read across. And so there we've got two lines that both bisect the tangent line. Now to work out the change in y, first of all, I need to use that line I just previously drew and find the point at which the line at 3 minutes meets the red tangent line and then extend across. And so this is now going to be my change in y. And my line at 3 minutes here. And the fact that my tangent that I started to draw my other line was at 0 is my change in x. And so we just read off for the change in y, we read off this value here. So we've got roughly 64. And then the initial value was 30. And then our change in x, our value is 3 minutes. And we started at 0. So we've got 34 over 3, which gives us our rate at 3 minutes as 11.33 centimeters cubed per minute. If you're tracking either the mass of the conical flask of the reactants and the products together over time and one was a gas, then we'd imagine the mass would decrease over time. Or if you were tracking the concentration of a reactant over time, then the reactant concentration is obviously going to decrease over time. However, you would do exactly the same thing. You would take a tangent, and say if we were asked to take that tangent at a certain time, let's say, for example, this was 1 minute here, what you would do is you would basically draw a cross on the tangent at 1 minute. Drawing a tangent to this, again making sure the area between the tangent line and the curve that you're doing it against is roughly equal. And this is even easier because you bisected both the y-axis here and the x-axis here. So that leaves you to easily work out that the change in y is the difference between here and 0. So that leaves us having completed both these specification points. If you have found this video useful, please leave a comment in the comment section below and ensure that you subscribe to the channel.